in this video, we're going to talk about an important concept in analytic geometry, something that is actually very central to the branch of analytic geometry, which are the conic sections. So, the word conic from the conic sections derives from the word cone, which is a geometric figure which can be constructed in the following way. Let A, this one here, and G, this line here, be two distinct lines that intersect at a point P. So, ito yung B, yung black line is G, while this one is A. Keep A fixed, kaya hindi siya gumagalaw, and rotate the line G, kaya umiikot yung line G dito, about A while maintaining the same angle between A and G. So, yun yung angle na yun. Yeah, it's the same angle. So, this collection of points swept about by G would be the cone. This one here and this one here. So, we technically have two cones. So, the conic, an abbreviation for conic section, are the curves that result from the intersection of a right circular cone, eto, this part of the cone here, and then a plane, which is this one here. So, note that the conics we shall study arise when the plane does not contain the vertex. It will later on, we're going to see what happens when the plane intersects or contains the vertex of our two cones. So, the conic is an ellipse. Here, it will be seen here in this GIF. Ayan. The conic is an ellipse if the cutting plane is not parallel to the generators. When we say the generators, these are the two lines that generated. So, sulat natin yun. When we talk about the generators, wait a moment, there you go. These generators, we are talking about the two lines. Oops, the two lines. There you go. The two lines that generated or created the actual cone. The two cones. Okay? So, ito yung dalawang line yun. Once the cutting plane is not parallel to this line or to that line, then the conic created is an ellipse. The conic section or the conic is the curved ellipse. If the cutting plane is parallel to the base, kagaya nito, it's parallel, then the ellipse is a circle. But if it's not parallel to the base, just like this, then it is just an ellipse. That is not a circle. A circle is also an ellipse, but the cutting plane is parallel to the base. Hence, it's a circle. Pag hindi naman parallel dun sa base, it's an ellipse. Once the cutting plane is parallel only to only one of the generators, ayan, and it intersects only one nap or one cone, then the conic form is a parabola. Let's wait for the GIF. Ayan. This one here is a parabola, only parallel to one of the generators that intersects only one of the naps. If the cutting plane intersects both of the naps, just like this, then it's called a hyperbola. Only one, it's called a parabola. If both naps, it's called a hyperbola. So again, the conic sections that we have would be an ellipse, and a circle is an ellipse, a special type of ellipse. Then we would have your parabola. Let's wait for it to show up here. Ayan, parabola, and then a hyperbola. Now, the moment our cutting plane touches or intersects the vertex, then the conics becomes what we call a degenerate conic because it either becomes a point, a line, or two intersecting lines. Kailan nangyayari yon? If the cutting plane passes through the vertex, it's parallel to the bases, at talagang dun sa vertex ang dumaan, then the conic degenerates from an ellipse or a circle to a point. If the cutting plane passes through the moving line, dapat may line, the word na line there, let's face it, the word line. the word moving line. And it's the degenerate form of a parabola. So, yung cutting line mo, parallel sa dito sa line na to, kapag nandito siya parabola, pero once na inusog mo and the cutting plane already contains the line parallel to it, it becomes not anymore a parabola. It simply becomes a line. If the cutting plane passes through the axis, the line that is not moving when you generate the cone, the axis, passes through the axis and passes through the vertex, then you don't have a hyperbola. You only have two intersecting lines. So the point is the degenerate conic of a circle or ellipse. A line is the degenerate form of a parabola, and the two intersecting lines degenerate form of a hyperbola. Now that we talked about the geometry part, let's talk about the algebra part. In general, the general form of any second degree equation is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Yan ang general form ng kahit anong second degree equation, because this also has a degree of 2. However, once we have b equals 0, b equals 0, then this term becomes 0. So, hindi na siya sinusulat. Once that happens, then we are sure that this is now a graph of a conic section. Therefore, it will look like this. Ax squared plus cy squared plus dx plus ey plus f equals 0. So, ito ngayon, if you see this equation without the xy term, then the second degree equation is an equation of a conic or a conic section. The question is, when is it a specific type of conic? Ganito. Once A is equal to C, then it is an equation of a circle. If A is equal to 0 or C equals to 0, it is a parabola. An ellipse that is not a circle, A is not equal to C, pero they're both either negative or both positive. A is not equal to C but are like sign, both positive or both negative. Once A and C are unlike sign, hindi na sila equal. A, for example, 2, negative 2. Not equal. They are unlike signs, or 3, negative 5. Then this equation becomes an equation of a hyperbola. Although we're going to go more into details as we go on each conic section, at least now we have a general idea of what conic sections are. Conic sections are. Take note that the definitions of the conics that we're going to go through, itong 1, 2, 3, 4, we're going to take them as locus of points satisfying a certain property at doon natin i-derive yung equation ng mga conics.